Okay, so what we're going to be doing is working through our second and last lesson in the chapter on function operations. And what we are specifically looking at today is something called composite functions. So with composite functions, there's two ways to notate. So just write two ways to notate. And the two ways to notate composite functions are something that looks like this, and sometimes I'll call this fog. It looks like FOG. But how this is read, this is going to be what we call a composite function. It's read F of G of X is how we would read this composite function. And what happens is this is what we call our inner function, and this is going to be our input function. And where we're going to input this function is into F, okay? So again, it's called F of G of X. Now this, why I call this fog is because this has an open dot. So diplomas often like to write composite functions to look like this. And then for all the examples that we'll do, I'll write it in this notation. Where students will get thrown on the diploma is sometimes they'll see it looking like this, looking like fog, and they'll think that this is multiplication, F of X times G of X. It is not. If it was multiplication, it would look like F times G of X, okay? So if that dot is open, it is represents the notation for a composite function. Okay, so this is just saying what we're always going to do with these composite functions is we're going to work with the inner function. So in this example, my inner function would be G of X, and we're likely going to be evaluating something for G of X, and then whatever our evaluation is, whatever we get, we're going to substitute and we're going to put it in our F of X function. Okay, so let's start with an application of composite functions. So what we're going to be doing is we're going to be evaluating a composition of functions using a table of values. So they give us two functions. One of our functions is going to be f of x, and one of our functions is going to be g of x. So what they tell me is they want me to evaluate f of g of -1. So what you start with is, remember, we always start with this inner function, which is g of -1. This is my table for my g function. So what I need to evaluate is what is g of -1? So here is where x is -1 and g of -1. Remember, we're always looking for the y value. G of -1 is 2. So this evaluation is 2. You put that inner function, what we just evaluated, in a bracket. And now I'm going to evaluate the f of 2. So once you get that inner function evaluated, you put that inner function into the outer function, which is our f function. So this first chart here is my f function, and now I'm going to evaluate f of 2. When x is 2, what is the corresponding y value? And when f is 2, the corresponding y value is 0. So how I would write this is I would write f of g of -1 is equal to 0. So let's try now b. Okay, so let's try b. What I want you to do is I want you to evaluate this inner function, which is f of 1. Go to your f table and evaluate when x is 1, what is the corresponding y value? When x is 1, the corresponding y value is -1. That then goes into whatever the outer function is, which happens to be f again. So then I go and I say, okay, I'm going to evaluate what is f at -1. So we're still in my f function table. And when x is -1, which is right here, the corresponding y value, which is my answer, is going to be 3. So how I would write this is f of 1 is equal to 3. I want you to take a minute to see if you understand this, and I want you guys to see if you could evaluate g of f of 2 and g of 2. See if you could do that. So again, evaluate the inner function first. So f at 2 is 0, and then put that into your outer function. And I'm just going to ask 2 different people. G at 2. Okay, so this first one, what would G of f of 2 equal? So G of f of 2. Amar, do you have that function done or that evaluation done?
Miss K?
Yep.
Oh, all right. Is it 1?
It is 1. Yeah, that's the correct answer. Okay, so for the next one, the next function was G of 2. Kyle, what did you get for this guy?
I got 2.
And that's the answer. Yes. Okay, flip your page. And now what we're going to do is we're going to evaluate a composition of functions using a given graph. So it applies the same way. I start with my inner function, which is my G graph. And this is the G graph here. So this is my G graph. And this radical graph is my F graph. So I need to evaluate when x is 2, what is the corresponding y value on G? So when x is 2, I'm actually right on my G graph. So I'd put a point here. And that corresponding y value is 0. Okay. Now what I need to do is I input that into my f function. And I'm going to find what is the f of 0. So when x is 0, which is right here, here's when x is 0. You say at 0, go up to your f graph. What's the y value on your f graph? When x is 0, and that y value is 1. So f of g of 2 to 1. I'll do the next one, and then you guys will do these two. So f at -1. So now I'm going to go to x is -1, which is right here. Where is that on my f graph? This is my f graph. So I'm actually right on the f graph. What is that corresponding y value? That corresponding y value is 0. Now I plug that into my g function. So g at 0. So g at 0. So let's find x is 0. Okay, so x is 0 is right here. Go up to your g graph, which happens to be this red graph. And g at 0 is 4. So my answer of g of f of -1 is equal to 4. If you guys could do f of g of -2 and g of f of 3 for me and get these two answers, I'll ask 2 different people. Gabby, did you finish this first one here, evaluate this?
No, I didn't get a chance to because I didn't think it was on the coordinate on the map, so I didn't know how to.
Okay, so let's check. Let's do this one. So Gabby, I'll get you to do this with me. So g of -2. So here's -2. The g graph is this guy. So what would be g of -2?
Would that be 8?
Yes, that would be 8. And then that gets input into your f function. So are you able to evaluate the f of 8? So here's 8. Does that point exist on your f graph?
Yes, that's 3.
Yes, right there. Yeah. So your answer actually be 3. For this guy here, g of f of 3. Maria, did you get this one?
Yeah, I got 0.
It would be 0. Yes. So that's the answer. How she would have gotten that. Maria, what did you get f of 3 was?
It's 2.
Yes. F of 3, you guys, would be right here, and that's 2. And then she would have evaluated g of 2. So she would have gone to 2, which is right here, and it lies on the graph. So that means that the point is right on the graph. What is that y value? It is 0. Okay, so that's how you would do evaluating a composition of functions using a given graph. All right, so now let's see another way that we could see questions. And here's another way that diplomas often love to give questions. So they will tell you things like f of 2 is 3. So what that means essentially is on the f graph, when x is 2, y is 3, right? That's what this means. And then on the f graph, another coordinate would be when x is 3, y is 4. So this is just an alternate way of giving you points on a graph, okay? So what they could then do is they could say, okay, based on this information here, please evaluate the following. So remember, we always start with the inner function, g of 3. So I need to go find what is the g of 3. So if I scroll through here, right here, the g of 3 is 2. When x is 3 on the g graph, the y value is 2. Then remember, you always plug that inner function into the outer function. And now I'm looking for what the f of 2 is. So the f of 2 is right here. That answer is 3. Therefore, this entire answer is 3. Okay, I will do B with you, and then I will get you to do C and D, and I'll pick 2 different people for C and D. So G of 2, that is my inner function. What is the y value on the G graph when x is 2? G of 2, the y value is 5. I then put that into the outer function, which is my f function, and I'm going to evaluate what the f of 5 is. So here's f of 2, f of 3, f of 5. F of 5 is 0. So the f of g of 2 is equal to 0. Okay, if you guys could do the g of f of 2 for me and evaluate that. And the g of f of 3, please. Eugene, do you have the g of f of 2?
Is it 2?
It is 2. Yep, that guy is 2. And then the next one, the g of f of 3. Haley, do you have that one?
Yeah, I do. Is it -1?
It is. Good. So that's how you would evaluate composite functions as follows. All right, now what we're going to do is we're going to be given equations. So I haven't given you equations yet, but right now it says, okay, here's the equation for f of x, and here's the equation for g of x. They want you to determine g of f of x, and they want x to be 4. So the first thing I do is I'm going to rewrite this because I don't like my functions. I mean, some of you will be totally fine with it like this. Again, like I said, the diploma likes writing it like this. But this, remember, that open circle tells you that it's a composite function. The outer function is g, and f is the inner function. So the outer function is g, f is the inner function, and what they want me to evaluate is when x is 4. So that's how I write this. So we really need to evaluate this inner function first, which is f of 4. Whatever that answer is, we're then going to put it into the g function. So method 1 is let's rewrite this exact thing. So we're going to solve the g of f of 4. Okay, so doing this inner function first, I need you to evaluate what the f of 4 is. So go to your f function and put in, we want to evaluate when x is 4. So 2 times 4 minus 5. 2 times 4 is 8. 8 minus 5 is 3. So the f of 4 is 3. And then what I need to input is I need to input that 3 now into the outer function, which is my g function. So here's my g function. I need to input a 3 here. So 3 times 3 would give me 9. So therefore, the g of f of 4, close 2 brackets, is equal to 9. That is one method we could do. The other method that we could do is we could determine the explicit equation. Now, even if you don't like this method, because I do find for this particular question, method number 1 is definitely the method I would do. You are going to have to, in this lesson, determine the explicit equation. So let's just practice this. So remember, this is what we are evaluating, or we're going to be figuring out. So let's take out this 4, though, and let's just put in an x, because I want to figure out the explicit equation for g of f of x. So this is the first time that we've done an explicit equation question. So f of x, you guys, the equation for f of x is up here. So this is my equation for f of x. So I'm going to take that f of x, and that is going to be my input equation, 2x minus 5. Where that is going to get input is into the outer function, which is g. So what this means is in my g function, so here's my g function, right? This is my g function. What I have to do here is into this function, every single time I see an x, I need to take that x out and I need to put in what they want, which is 2x minus 5. So the g function is 3 times x, so it's going to be 3 times, and then the x comes out and 2x minus 5 goes in. You would then distribute that 3 to get rid of the bracket. And you would be given, or you'd get 6x minus 5. And nope, that's incorrect. 6x minus 15. That is your explicit equation. So now what I could do is I could now evaluate the g of f of 4 simply by inputting 4 into my explicit equation when I see x. So that would be 6 times 4 minus 15. 6 times 4 is 24 minus 15. And 24 minus 15 is 9. So many of you should see was the easiest way to do this, but you will have to be able to figure out explicit equations and then input the 4 into that explicit equation, and this is how we would do it. So that will be just a little bit later on in this lesson. Okay, this one here. So I will do this one, and then you guys will do this one. So they give me f of x, they give me g of x, and they give me h of x. So now I actually have 3 different functions that I could be working with. They want me to determine the h of 2. So if I was determining the h of 2, here's my h function. I would simply put a 2 in here, and then I would take out that x and I would put in a 2. So the h of 2 is going to be 2 squared is 4. From here, I put that answer into the outer function, which is still h again. And I'm going to calculate what the h of 4 is. So going back over here, go back to your h function, stick in a 4, take out that wherever you see an x, take it out and put in a 4. 4 squared is equal to 16. So the h of 2 is equal to 16. So see if you could evaluate this one. So find your g function, which is right here, and put a 3 in, evaluate that. Once you figure out what that is, put that number, whatever number that is, into your outer function, which is your f function, and see if you could get that answer. Okay, Olivia, do you have that one done?
Just 30 seconds.
Sure, yeah. Finish it off and then let me know what you get. Actually, Olivia, could you first tell me what you got for the g of 3, just to make sure that you did that correctly?
9.
Yes. G of 3 is 9, and then she's now going to put 9 in this function, in the f function, and calculate what she gets there.
36.
The answer is 36. F of g of 3 is equal to 36. Okay. Determine the composition of 2 functions. What they want us to do here is we're getting explicit equations. Give us practice with explicit equations. So let's actually write that down. And if any of you need more review on this, some of you would have watched this last night, but this is podcast lesson 3C part 1. Okay, so f of g of x. So the first thing that I'm going to do is take my inner function, which is my g of x function, which is this guy right here, x squared. That is going to be input into my outer function, which is f. So now what I need to do is I need to look at my f function, which is this guy right here, and I rewrite this, but this x comes out. Wherever you see an x, you're going to put in what they want for x. So x comes out and x squared goes in plus 1. So the new explicit equation is this right here, which is y is equal to x squared plus 1. They want us to do the domain and range, but we'll do that at the end. We'll figure out all the explicit equations first and then do the domain and range at the end. Okay, this next one, explicit equation of this guy. So the inner function is f of x. I go here and I'm going to take this f of x, which is x plus 1. Put that inner function in a bracket. And I'm now going to input it into the outer function, which is my g function. So my g function is right here. So what I have to do with this g function is x comes out, right? And what's going to go in is x plus 1. So I'm going to take that x out, and I'm going to put in, wherever I see an x, I'm going to input an x plus 1. But then remember that there was a squared here. So this guy right here is my explicit equation. Y is equal to x plus 1, close that bracket and square it. So that's one explicit equation. This is the second explicit equation. This third one, take that g of x and say, what is g of x? So I go back over here. I'm just going to erase. So g of x was x squared. That is now my input function. That is going to be input into this outer function, which is g again, doesn't matter. What we do is we now look for that g function, which was the same thing, but I'm going to take out that x and I'm going to put in an x squared. So I'm going to put like this squared on the outside, because remember, whenever we take a variable and input something for that variable, it goes in a bracket. And they want that x to be removed, and they want x squared to go in. How you would simplify this is a power to a power, so you would multiply a power to a power, and we would get y is equal to x to the power of 4. That would be the 3 explicit equations. How they want to end is they want you to write the domain and range for each explicit equation. So to save some time, instead of you guys typing this into your calculators, I'll show you what I've done. So 3 of these, y1, 3. So I'll just bring a calculator so you could see. So here's that first equation, x squared plus 1. So I'm going to just graph, I've got that equation selected. So if I graph this, it gives me a parabola, and the minimum value is at 1. So the domain of this parabola is xer, and the range is y is greater than or equal to 1. So let's write that down. The domain is xer, and the range is y is greater than or equal to 1. If I now graph the second explicit equation, which was this guy here, x plus 1 in a bracket squared, here's what I would get. It is a parabola still. It's just been translated 1 unit to the left because our h value is -1, right? So the domain of a parabola is xer, so our domain doesn't change, but my range is now y is greater than or equal to 0. So I'll do this one in red. The domain of a parabola does not change, xer, and the range, it was on the on the x-axis, so the range was y is greater than or equal to 0. For this last one, we have a polynomial degree 4. So let's look at the graph of a polynomial degree 4. And see if we could write what the domain and range are. Okay, so again, it is going to be parabolic in shape. So the domain is xer, and the range, it's more spread out down here, but the range is still y is greater than or equal to 0. So for this one, parabola still xer. X belongs to the set of real numbers, which means, remember, if we were doing in interval notation, it would be -infinity to infinity. And the range was y is greater than or equal to 0. If I was doing this in interval notation, the smallest y value is 0, and it is equal to, so I'd give it a square bracket. The biggest y value would be infinity, which I would give a round bracket. Okay, let's look at this. So given the functions, so look what they've given me, 3 functions, f of x, g of x, and h of x. So they've given me 3 different functions. Now we're doing something we haven't ever seen before. So we're going to be doing a composition of functions, and we're going to be letting it equal to a number. Okay, so we haven't done that yet. And then they've done this weird thing, and they've said, what's h of a? And we've never seen this before, because normally we see h of x, right? So what this means here, so I don't want you guys to panic when you see that, h of a, which is my inner function, what that simply means is to go to your h function, which is right here, and they want you to replace the x with an a, is all that means. If they tell you, what is the h of a, you go to that h function and you replace the x with an a. So what the h of a is equal to is a plus 3, the square root of a plus 3. So if I rewrite this, g of h of a is equal to 13. Now what I could do is I could take out this inner function, and the h of a I have right here. The h of a is the square root of a plus 3. And where I now need to put this is in the outer function, which is my g function. So this needs to go into my g function, okay? And this is going to be equal to 13. So now, again, I need to, in my g function, wherever I see an x, I need to put in an square root of a plus 3. So what was my g function? Here's my g function right here, okay? So in this function, x must come out, and the square root of a plus 3 must go in. So what this would be, the g of the square root of a plus 3 would be 5 times the square root of a plus 3. So we'll write that. Okay, and then minus 2. So don't forget, in our g function, we write the entire function, and we just take out the x and put in our inner function. So I've got to include that minus 2. And this was all equal to 13. So this is what we have. And what the question actually says is it says determine the value of a. So what we now need to do is to isolate this radical, because we're eventually going to solve what a is. So from this point here, we're going to be doing what we did in Math 20-1, which was solving radicals. So the first thing I want to do is get rid of this negative 2. It's not in the radical, right? So we can get rid of a negative 2 by adding 2 to both sides. What I would have is I would have 5 times the square root of a plus 3. And that is equal to 13 plus 2 is 15. My radical is still not isolated. I've got a 5 in front of it. My radical is being multiplied by 5. So to get rid of that multiply by 5, we're going to do the opposite, which is dividing both sides by 5. And then I would get the square root of a plus 3 is equal to 3. From here, 20-1, once you had radicals isolated, we could now get rid of the radical sign. So you would say to yourself, okay, well, how do I get rid of this radical sign? The opposite of square rooting is squaring. What you do to one side, you do to both sides. When you square a radical, you are left with just the radicand. So a plus 3 is equal to 3 squared is 9. Subtract 3 from both sides, and we get a value of a, and a is equal to 6. If this was a diploma question, you could check this. So here's how we would verify. I would go back up here, and we just evaluated the h of a. So what I'm going to do is I'll show you how we would verify this. Actually, not only if it was a diploma, but this is like a perfect question to put on your exam next week. So the g of h of a, I'm going to verify that this is in fact 13. I got A. What did we get? A is 6. So let's calculate what the g of h of 6 is. So the h of 6, if I go back up here, and if I put in a 6, h of 6 would be 6 plus 3 is 9. The square root of 9 is 3. And then I'm going to plug that into my outer function, which is my g function. So I'm going to go over here, and I'm going to say, okay, what's the g of 3? So if I put it at 3 here, 5 times 3 minus 2. 5 times 3 is 15. 15 minus 2 is 13. So my left-hand side would give me 13, and my right-hand side is 13. If left side is equal to right side, you are verified. Okay. Let's now look at determining domain for composite functions. So there's 2 steps here. So let's actually just highlight these 2 steps, and then we'll do some examples. So step 1, when we have a composite functions and I ask you to determine the domain, we could do like we did in that last example and find the explicit equation, but we actually want to find, we do want to apply these 2 steps. So step 1 is we find the domain always of the input function. So we need to basically see if there's any restrictions on the input function. And then step 2 is we construct the composite function. So that's finding the explicit equation. So we're going to get the explicit equation. So maybe I'll write that down for step 2. So step 2, when you construct the composite function, what you're doing is you are finding the explicit equation. And then what you're going to do with that explicit equation is you're going to see, are there any restrictions on that equation? So for example, let's say you get a rational, so 1 over x minus 2. Let's say this was your explicit equation. There would be a restriction on this, and the restriction would be x cannot be equal to 2. Okay, so again, step 1, we always find the domain of the input function. Step 2 is we find the explicit equation, and we see if there's any restrictions on there. If there are restrictions for the explicit equation, we're going to add them to step 1. So we're going to say that we'll keep this restriction and this restriction. Or if there's an overlap, what we do for an overlap, and again, this will make sense once you see examples, we use the more restrictive domain. Okay, so I'll show you, let's explore this by looking at actual examples, and then this will make sense. So I'm going to give you, first of all, this examples of overlap. So let's say you guys, you found these restrictions here. One of your functions had the restriction of x is greater than or equal to 2. And let's say the other function had the restriction of x is greater than 0. So if you had these 2 functions and these were the restrictions, or these were the domains, like this was the domain of the first function, this was the domain of the second function, what you want to do is you want to find the overlap. So you would use a number line. X is greater than or equal to 2. So if I put 0 here, 1, 2, what this domain would look like is at 2, it's saying it could be 2. So I'd circle this in, or I'd color in this circle. And then it's saying the domain of this is any value greater than 2. So this was what my domain would look like if we had a domain of x is greater than or equal to 2. This domain here, x is greater than 0. I'm going to just write it above this number line, but x cannot be 0. So at 0, I would put an open circle. But then it's saying x could be any number greater than 0. It can't be 0, but it could be any number greater than 0. So that would be this here. What it says, this use the more restrictive domain. What you want to think about is, where do these values overlap? Where does this overlap with this? And the overlap is like the pieces overlap here, and basically right here is where the overlap occurs. So if we had these two domains, what the new domain would be of the explicit function, so the new domain would be where they overlap, which is x is greater than or equal to 2. So between these two, what was this guy here, and that is the new domain. It's where the overlap is. I'm going to show you 2 examples of this, of finding the domains. Okay, given the functions here, so they've given us 2 functions, f of x and g of x, determine an explicit equation for each composite function, then state its domain. So let's just for now worry about determining the composite functions. The inner function here is f of x. This is f of x. 1 over x minus 2. That is my inner function, and that is going to be input into G. Now, step 1 on that previous slide said we always find the domain of the input function. So this guy here, the domain of this function, we could never divide a number by 0. X could not be equal to 2. So if you punch this rational into your calculator, 1 over x minus 2, what you would see is you would see x could be any number, okay? X could be any number, but there would be a vertical asymptote at 2. So that's my restriction. So I need to keep that restriction. So now what I do is I found the domain of my inner function. What we're going to do is we're going to input this inner function into my outer function, which is G. So here's G. Every time you see an X, take out that X and put in 1 over x minus 2. So I'm going to put, for this, I'm going to take out that X, and I'm going to put a 1 over x minus 2. And I'm going to square that minus this guy. So take out that x and put in x minus 2. Okay, we're going to clean this up. This square applies to the 1, and it applies to this binomial, which is x minus 2 squared. Minus, we've got a 1, and I've got that binomial. Okay. This is again going back to rationals. How would you further simplify these 2 rational expressions? You need to get common denominators. So I have x minus 2 twice here. Okay, so if you want to see this written a different way, I could erase this 2. And this bracket is really written twice. So this first fraction, I've got x minus 2, x minus 2. This fraction, I only have 1 x minus 2. So what I'm going to do is I'm going to add another x minus 2. to get common denominators. If you add an x minus 2 on the bottom, add an x minus 2 on the top. So now my denominators are common. X minus 2, x minus 2, x minus 2, x minus 2. So my denominator is x minus 2 squared. When you are adding or subtracting rational functions, you simply, once you have common denominators, you simply add or subtract the numerators. So I have a 1 minus, over here I've got 1 x minus 2. I can further simplify by having 1 minus 1x plus 2. And this could further be simplified. 1 plus 2 is 3 minus 1x over x minus 2. That is your explicit equation. So you need to be able to figure out explicit equations. So this is how you would do it. Is there a restriction on this explicit equation? Yes. We could never divide by 0. So x could not be equal to 2. If I look, so the domain of this is x cannot be equal to 2. Back and I look at that inner domain, it was the exact same thing. So because they had the same domains, the domain is going to remain x cannot be equal to 2, but other than that, x belongs to a set of real numbers. So if you were to type this into your calculator and graph this, what you would see is you would see x could be any number except there's going to be an asymptote at 2. Okay. Let's do B. B is much more simple. G of x. So that's my inner function. My inner function of g of x is x squared minus x. This was g of x. If I said, are there any restrictions on this domain? You could check by punching that into your calculator, but the domain of that, if you punch this in, would be XER, right? So the inner function domain is XER. What we do is we take that inner function and we put it into F. So here is F. Okay. So what I'm going to do is that would be 1 over, take x out and put in x squared minus x. And then there was a minus 2 at the end. That is the explicit equation, but we need to find the domain of this. And in order to find the domain of this, we need to find, like, are there any restrictions? We can't divide by 0. So what we would need to do is we would need to factor this denominator. And I'm looking for what gives me a product of -2 and a sum of -1. So if I were to factor this, what multiplies to negative? So it's going to be 2 and 1. And I need a -1, so this guy's going to be negative. -2 and 1. Factors would be x minus 2 and x plus 1. This is, again, the explicit equation just factored. I would need to state my restrictions. X cannot be equal to 2 or -1. X cannot be equal to -1. And that would be my domain. If I said, what is the domain is x cannot be equal to 2 or -1, but other than that, x would belong to the set of real numbers. Okay, so that's just how we do domains. You always just tell me the domain of the inner function, then you do your explicit equation, and you find any restrictions, and you're going to put those restrictions in your domain. Okay, we will finish this off. I think we've got 3 examples left. Okay, so this looks like it's not a diploma question, but it's going to be from your workbook. Okay, so this again is going to be a composite function. And we've got three different functions, f of g, sorry, we've got our f function, our g function, and our h function. And look at what they want me to evaluate here. So we've never done a composition of three different functions. Whenever you see a composition of three different functions, this would be what's called standard of excellence. Standard of excellence. They love having standard of excellence on the diploma, and I will have a standard of excellence on your exam next week. And you guys, it's interesting because normally what becomes a standard of excellence is the top 20% of the class get these questions. That's what make them standard of excellence. But honestly, the majority of you on this test would get this question. So this, again, what this would be f of g of h of -8 is what this is. So the outer function is f, then g, and the most inner function is h. I would have to close a few brackets. You'd close 3 brackets if you have 3 different functions. Close by 3 brackets. Okay, so it looks scary, but it is really not. We always start with the inner function, which is my h function. Here's my h function. They want me to evaluate when h is -8. So into your absolute value, take out that x and put in -8. -8 plus 2 gives you the absolute value of -6. And if I said, well, what's the absolute value of -6? You just take the positive of that number, which is going to be 6. So h of -8 is 6. We now input that into the g function. So we go from the innermost to the outermost. So now we're going to evaluate the g of 6. And we're going to figure out what is the g of 6. So go to your g graph, which is right here, and let's plug in a 6 there. 3 times 6 plus 2, which is 18 plus 2. 18 plus 2 is 20. So g at 6 is 20. That gets inputted into your outermost function now, which is my f function. So f of 20, here's my f function. And I'm going to put a 20 in here. So I'm going to evaluate what f of 20, I'm going to take out that x, and I'm going to put in a 20, and I'm going to square it, minus 20 squared is 400, minus 1. Your answer is 399. Okay. So just to see if you understand this standard of excellence question, let's do this guy. So again, standard of excellence. You'll see this question I'm going to be giving you for this weekend a quiz to do. And this will be very similar to what would be on your test. Okay, determine k of x. And it's a composition of h of g of f of x. Okay, so how we would do this, though on the test, I would give you what x is and we would evaluate. So this would be a standard of excellence determining the composition explicit equation. So how I would rewrite this is k of x is equal to, that's my outer function. So it's h of g of f of x. Whenever you have three functions, close three brackets. Always start with your inner function. The inner function is f of x, which is the square root of x minus 1. That is going to be input into your g function, which is right here. So now what I'm going to do is in this g function, take that x out and put in the square root of x minus 1. We're going to square it and we're going to add 3. So how I'm going to do this. That x goes out. And I'm going to input square root of x minus 1. That goes in a bracket. Remember, you always substitute in a bracket, and there's a square on the outside of the bracket plus 3. This is now my g function. This crazy thing, actually, I'm going to put this in its own bracket. This is going to be, oh, actually, sorry, we could clean this up. I was like, well, this is, I was saying to myself, this is looking a little bit crazy, and diploma questions always clean up very, very nicely. So the one on Friday, or the one that you write next Friday, will clean up very nicely. Okay, here's how this cleans up. You have the square root, and then we're squaring a square root. If ever you square a square root, so for example, if I gave you the square root of 5, and if I said square that, if you type that into your calculator, the answer is the radicand. So what is the square of a square root? That answer would be x minus 1 plus 3. Join these constants together and you would have x plus 2. So this now was my g function. And where am I inputting this x plus 2? Into the outermost function, which is h. So yes, all of these, you guys, if we give you like diploma questions, the questions next on your unit exam or your exam, they clean up very nicely. Something like this would always happen. Now I've got to find my h function. When I see an x, I've got to input x plus 2. So h is this guy right here. So this comes out and x plus 2 in a bracket goes in. So my answer, it was 2 times x plus 2 minus 5. You could get rid of your brackets by distributing in the 2 into the bracket. 2x plus 4 minus 5. 2x minus 1. That is now my explicit equation. And what they want me to call that explicit equation is k of x. From here, what you would do is on your test, what I might do is, again, I might say, find the explicit equation for this, but then I might say, and then calculate what that explicit equation at 5 would be. So then what you would simply do is you'd put a 5 in here and your answer would be 9. The k of 5 would be 9. So expect a standard of excellence question and expect that it will clean up very nicely. And honestly, probably 80% of you will get it. Okay, we've got one last question to get through, which is this guy right here. So if f of x is equal to this, and g of x is equal to this, please determine the f of g of x, which is equal to 5. So how do we do this? We do the same thing we've always been doing, and we start with this inner equation. My inner function is g of x, which is 2x. That is going to be input into this outer function, which is f. They want this, though, equal to 5. So what I now do is I now must go to my f function, and in my f function, I must input every time I see an x, I must input a 2x. So here's my f function, take that guy out. 2x goes in, right? So I'm changing this to be 2x, and then there's a plus 3, and that is equal to 5. What would we be solving? We'd be solving for x. So subtract 3 from both sides, and we would get 2x is equal to 2. Divide this by 2, divide this by 2, and x is equal to 1. Again, we could verify this. So how we would verify, and you'd be required to verify on your test, what we were verifying was f of g of x is 5. And then on a test, what you would do is you would subtract this, or sorry, you would delete that x, erase that. And we're going to verify when x is 1. So the g of 1 2 times 1 is 2. That gets input into your f. What is the f of 2? Two plus 3 is 5, which is equal to 5. And you'd say left side is equal to right side. It verifies. Okay. Take a minute and write in f of x. So find what f of x is. So f of x is x plus 3. They want me to input that into this outer function, which is g. And then they say, please let it equal to 20. So you say, okay, now I got to evaluate this outer function. In my g function, whenever I see an x plus 3, or sorry, whenever I see an x, it comes out and x plus 3 goes in. So my g function was right here. This x comes out and x plus 3 goes in, but don't forget that 2. So it's going to be 2 times x plus 3. That is equal to 20. From here, get rid of your brackets and solve for x. Subtract 6 from both sides. And divide by 2. We're getting x is equal to 7, which is the final answer. And what we need to do now is we need to verify. Okay, so what we're verifying is this, but I'm going to input a 7 here. So I'm going to verify g of f of 7, 2 functions, you close 2 brackets, is equal to 20. F of 7, what's f of 7? F of 7, hopefully you just see as 10. Input 10 into your g function. 2 times 10 is 20. The g of 10 is 20. On the right-hand side, I had 20. Left side equals right side. So that concludes the lesson. It was a bit of a longer lesson. but I'm going to give you your homework and then we'll talk about the homework. So here's your homework. And what I'm going to do is I'm just going to stop recording this lesson and then we'll talk about it.